At this point, we already learned how to find the displacement, what is the velocity of an object, and what is the acceleration, how to separate those parameters into components and in terms of vectors, and how to find the x components and y components of vectors. Now we're ready to jump into our next chapter, which is dynamics. Dynamics is basically focusing on analyzing the forces affecting the objects, and hence those forces will affect the direction and the magnitude of velocity or acceleration or even displacement for object. And we will learn about Newton's first law, second law, and third law. We will learn as well about the universal gravity and how to apply all the laws created by Newton to be able to describe gravity in more descriptive terms. When you apply a force on an object, this force can change the shape and the dimensions of the object. It can change the speed and the direction of that object. You can see here there's a rubber ball. When you push your hand on it, it will squeeze due to the force being applied on top of this ball, so you can change the dimension of the object in this case. When you push on the ball, there is a force pushing back to bring the ball to its normal shape, and there is a force as well that can be exerted to the ball to the right or to the left, and it can give it a certain acceleration or a certain speed or even a certain displacement. You can as well with force stop the motion of the object. You can as well speed up the object and increase his speed or slow down his speed. And as we mentioned, you can change the direction of motion using force. Force is represented in the symbol of F capital and an arrow. That means it is a directional value, and the units of force in SI units is known as Newton. Force, similar to velocity, having a magnitude and a direction, you can represent the force on the Cartesian with vectors, and it will have a certain magnitude and a certain direction, and you'll be able to split this force into components similar to any vector we talked about previously. You can as well represent the force in the polar coordinates to be able to analyze all the components related to that force. Force can be measured using a calibrated scale. This scale having a hook over here. Any objects you hang it on this hook, it will be able to pull the spring of this scale at a certain point, and the number that the pointer is pointing at would equal the amount of force that object is applying on that scale. In this case, we have a bucket. The bucket have a certain weight, as you know. Let's say this bucket is filled with water or with sand, and there is the weight of the bucket itself. Let's assume it is made out of steel. So this bucket has a certain weight. The weight will be pulling the bucket downwards. So when you hook it up on the scale, it will be trying to pull the hook downward, which will move the slider of the scale downwards and point at a certain number. That number would equal the amount of force that bucket is applying on the scale. And of course, the bucket has a certain weight, and the weight is related to force, as we will learn as moving forward. To measure the force of gravity acting on an object, you basically attach the object to the end of the spring, and you observe how much the spring of the scale is stretched, and this would be the weight of the object, which is the force of gravity acting on an object. Force of gravity is represented by Fg. That means how much force does the gravity apply on that bucket, and consequently how much force is being applied on the scale in this case.